Welcome to the AM panel, Supply Chain, Cybersecurity and Intellectual Property. I'm happy that you are back again in our live stream, and I'm happy to have you here at our stage. Yeah, let me tell you one story. It's some years old. I once visited a manufacturer of molds, of tool making, tools for mold making, and I asked him, are you using cloud technology? It was really new at that time, and he nearly got a bold look, and I thought he would push me out of the office, because he was so reluctant in losing his intellectual property that he forbid everything. No internet connection, no USB stick, nothing. And he was very confident about his way to go. I don't know what he's doing today and if the company still exists, but I found it very curious to just be so aware of losing one's intellectual property. But nevertheless, it's today a hot topic, because even for example, especially I want to say, especially in an industry like additive manufacturing, where you have a digital chain from the CAD file to the product, and so that's a very hot topic. And I'm very happy to have the people here on stage who can give the answers, how we secure and how we keep the companies like the toolmaker I experienced, that they have a running business and can use their cloud services still today. Yeah, so I'm very happy to have you three here with me on stage. Moritz Kolter. Moritz Kolter is Group Manager Digital Production of RWTH Aachen, Chair for Digital Additive Production. Moritz, good to have you here.
Yeah, good to be here.
Dr. Philip Reeves, he's Managing Director of Reeves Insight, coming from far. Good to have you here. I hope you had no jet lag or something.
I'm good.
Okay, perfect. Chris Adkins, Director of Product Security from Materialise.
Thank you. Thanks for.
Good to have you here, Chris. Yeah. We want to talk, or this morning we already talked about aspects like cybersecurity, and we had the automotive industry here on stage. And I think we are not talking about parts of the motor or something. Maybe parts of you put in a truck where you have some grippers or something like that. But nevertheless, you don't want to have them printed anywhere in the world. You just want to keep your intellectual property where it belongs. How do you secure it, Moritz, in your business? What are you doing on the topic of cybersecurity and securing the intellectual property? Give us a short insight.
So basically our approach is that for, I say, file uploads, clouds, there are firewalls, there is technology to protect that. But when it comes to sending data from the cloud to the machines, there we see a gap, and we develop a streaming approach that we can stream the manufacturing information directly from the cloud to the printer, so that we can basically bring back the flexibility to additive manufacturing. Because if you just use AM in a centralized way and you just produce for yourself, then you lose a lot of the opportunities you could have with additive. But yeah, no one wants to share their 3D model. No one wants to say, okay, print that part for me. Here are my process parameters. Here's my super secure part. No one wants to do that. And in the end, yeah, AM promises to have like a digital supply chain to reduce lead times, to reduce transportation efforts, and so on. And we think that that missing piece, like the last mile transportation to the machine, is key. And there we're developing that streaming solution that we can, yeah, have all the data preparation already done in the cloud or someone centrally where you can control it, and then or the vision is that you can use any printer worldwide, and you just stream the information, and you make sure that the file is not changed during the transportation, the digital transportation, and beyond that you can control how often the part is printed and who is printing and using the part in the end.
We had that topic already some minutes ago. Yeah. How do you secure it, that it's not printed more times than it's allowed to?
So the streaming approach works in a way that you send layer by layer. So you can basically compare it to Netflix, where you have a video stream and you on any device you can get the video, but you don't store the video. So we just stream one layer after another. We have some encryption, obviously, on that streaming channel, and kind of a certified gateway on the machine to make sure that there's no copy made or that functions like just replay on the machine doesn't work anymore. And that way we can control to which printer we send and how often they print.
Are you working together with industry companies?
Yes, so in that regard, we're working together with different companies. So we have machine manufacturers on one side, because we need to bring the technology to the hardware somehow. And then obviously we are experts for additive manufacturing, for the process and for the digital side, but we also have, for instance, Vivo System in the consortium, who's dealing more with the security and encryption questions, I would say, because yeah, I leave that to experts.
Okay. Phil, you said you see a lack of current demand for secure data exchange infrastructure within AM. What are the reasons for that point of view, for that assessment?
Yeah, I've done quite a lot of analysis over the probably last 2 or 3 years with some big OEMs, and I think the general consensus is, at the moment, the supply chain is quite well controlled, and in a lot of cases, the additive manufacturing element is being done by companies who were traditional manufacturers anyway. They were part of the supply chain for CNC machining or for casting or for heat treatment. And security protocols, data exchange protocol already exists. So additive is no different in the traditional supply chain. I think we're only just starting to get to the point where companies are thinking about this idea of more distributed manufacture, shifting their production from one supplier to another. And at that point, you then have to question, well, you don't have the same documentation, you don't have the same quality management systems, you haven't audited the way that they deal with data. So I think we're a little bit ahead of ourselves in that the demand is not necessarily there yet to have an infrastructure for secure data exchange, because we're still thinking in a mindset of traditional...
That could be a solution.
Yeah,
we just
exactly.
I think something you want to have in the market.
Yeah.
You want to see.
Yeah, I think that one of the key things in all of this is that the main uses of this technology are still high value, high criticality applications. And therefore the importance is, can I trace where the data went, but can I trace everything beyond the data? Can I trace the machines? Can I trace the log files? Can I have visibility of everything coming back, that kind of the digital twin to the thing that I'm sending?
That would not be possible with your system, right?
Partially. So the streaming, as we have it right now, is a forward loop. We know that which data we have sent to the machine, and we know that it arrived securely without any manipulation on the machine. The next step, maybe in a follow-up project, is to close that loop that, for instance, we have process monitoring also being streamed back to the cloud where the original data is coming from, and then there you can compare and see, okay, is the part printed on the machine in the right quality? Are the process parameters met, and so on and so forth. So that could be added to the already existing streaming protocol, and that's something we want to then approach in the future. But I think right now the first step is to just bring it to the market and to see for which applications it makes sense, and then to add on that, because as Philip said, the supply chains are already existing, and you have to check which type of certifications and stuff like that you also have to kind of tackle and to consider in such a protocol.
Chris, what is your assessment to the topic? Materialise is a big company,
right,
and I think that is a question your customers are asking frequently. How do you answer these?
So Philip had a great point that we're a little bit ahead, and so I originally started with Identify 3D in 2014. Our goal was to develop security solutions to protect the IP throughout the digital supply chain. And we were acquired a year ago by Materialise, and the reason Fried wanted to acquire us was because he sees that distributed manufacturing is one of the big future growth engines for additive. And holding that back is the threat of IP and the risk to IP through that. So, so at Materialise, we want to enable our customers to be able to utilize distributed manufacturing, be able to manufacture wherever they want, and have that full security.
Okay,
control of risk.
Can you explain how the solution works?
Sure.
You're using?
Yeah, so the solution, what we do is we capture the files to protect, so a build file in most cases, and we set a set of license parameters around that, of how that file can be accessed. And then we have applications throughout the workflow that allow you to authorize exactly what organization has the authorization to manufacture. So if you're an engineering house and you want to have a service bureau manufacture a part, you can authorize them to manufacture 10 parts. The service bureau, using our software, will receive the license, will receive the encrypted package of data files, and then they can authorize their individual machines to print up to whatever their order quantity is. And then once the print is completed, the files are erased, and then we send back the tracking information that defines exactly where the part was manufactured, how many parts were manufactured on the dates, who authorized the manufacturing or the distribution of those parts throughout the chain. So if you're the owner of the IP, you see the full history of both the licensing, the authorization, and the production.
Mm-hmm. Phil, do you see a certain industry sector having a more of a demand of a secure way to work together with the different partners in the supply chain?
Yeah, I think there's a difference in vertical markets and their, if you like, their desire to have intellectual property security and then data traceability. And I think the aerospace and the medical guys, it's much more about the data traceability and that control of who was it that produced the part on what machine on what day to what standard with which operator. Because that's about the data that you send ultimately results in a product that could fail. And therefore, traceability of data is really, really important. The flip side of that is they're less concerned about the intellectual property in terms of the design or the STL file, because it's in a very, very controlled supply chain. So the chance of somebody making a spare one, putting it in their bag, taking it home, and then trying to sell it to somebody who has an A380, very unlikely. That's different to consumer goods, where it's much more about the intellectual property and not wanting the IP of the design to fall into the wrong hands and have mass manufacture. So I think there is a difference between the vertical markets and what they want.
Which vertical markets would you point out? So which one are? So we have defense, for example, or aviation. I think these one would be most critical.
Yeah, defense and aviation is much more about the security of the data. I think medical, and I sit on the board of a medical materials company, and a lot of our pain is about the ISO 13485 digital element of the supply chain and how we can only ensure that our material is only ever used on a machine that is validated, with the software that's validated, with the operator that's trained. So and again, we'll probably come on to this, but this idea of securing and sending STL files to us is a nonsense. To us, it's about securing a build file that will only work on a machine with a set of software, because our traceability relies on that. I can't send STL files to anybody, even if they're encrypted, because I have to be able to show the FDA that that medical device was made on a certain machine with a certain software patch with a certain set of parameters.
Yeah,
so I think different verticals are going to have very different requirements.
Yesterday we had a presentation here on stage, printing and future printing organs, livers and hearts, and you sure will keep control about where's my heart right now. Yeah. Yeah. Can you answer? Can you cover these questions Phil has?
So I think it's depending on if you're in such controlled supply chains, I think it's quite hard, and solutions have to really be holistic and think of a lot of different things. But as you mentioned, B2C market, for instance, but also I'm thinking of the spare part market. So we just had the example of Daimler trucks. I think there are a lot of, I would say, easy spare parts where it's just about lead time, just about digital warehousing, on-demand production, and where you want to leverage different aspects of additive manufacturing. So it's not about as much about quality, it's more about like being fast, saving CO2 emissions and so on. And I think in these areas, it's more about just making sure you don't lose your ownership, you don't lose your IP. And I think for those use cases, it's much easier, and the development path to enable those is quite close. But on the other hand, we have that chicken and egg problem that machine manufacturers say, okay, I just want to open my machines or have that technology in my machine integrated if there's already an existing market. And on the other hand, the market says, okay, if there's no solution, there's no way to do that. So I think the tricky question in that regard is how to get the hardware vendors on board to also support those solutions, and maybe thinking of having a standard when it comes to machine communication and to send manufacturing information along the entire process chain.
Mm-hmm. Chris, does you or your company has experiences with the pharmaceutical applications and questions Phil raises here?
Yes, that's a good point. We have, so you're right, we have customers that are concerned about the confidential nature of the parts, and then others that are really concerned about either the integrity or making sure the process is defined. So we've had customers in the past who have manufactured parts, realized 6 months later that those parts, certain parts were manufactured on a machine that had a down level firmware, and they had a defect and had to go in the field and replace all their parts because they didn't have the tracking to identify which parts were made by which machine. So that's one of the licensing elements that we enable, is allowing you to license the machine, the software firmware revision number, so that you can control not just from the intellectual property, but also control the process from a quality perspective, make sure that the processes are repeatable. And then you also have an audit log of exactly what was done, because several industries, medical, and even in aviation too, you have to have those records to be able to provide to auditors when the time comes.
Mm-hmm. I think you have some experience in the defense regulation area. Give us some insights about their demands. What does the defense? I think it was the U.S. defense. What do they demand from you?
Yeah, so the Defense Department, they're going through the same kind of transition as everyone else of moving from prototype to actually doing production printing. And so just recently in the last few years, they have changed some of the regulations where previously machines were mostly offline and that was acceptable cybersecurity behavior, but now all machines have to be online and the machines have to support a fairly standard set of cybersecurity.
Okay, so totally different aspects.
It's a totally different aspect now. So that's inside the four walls of the defense. If you're a contractor, now coming next year, you have to have a CMMC certification. So your organization has to be certified by a third-party auditor for their cybersecurity.
Is it comparable to the certification the FDA needs? As in certain aspects, for sure.
There's some similarities, but the CMMC is just focused on cybersecurity.
So the FDA, to describe it, is a Food and Drug Administration, and they have certain demands on the food and pharmaceutical area. And so if there are certifications, you have to follow quite a lot of steps and to have a big documentation about every step and rights management. The
FDA, it's not, I mean, the FDA now says that within an ISO 13485 facility, you have to have a digital QMS. So you have to have a digital quality management system. And within that, you have to highlight how you will deal with digital security, but it's not prescribed what you will do.
Okay. And that's a difference to the defense sector. There it's described, right?
Right. It's very, there's 110 controls that you have to practice. You have to demonstrate to an auditor that you're practicing those. So if you're an OEM selling into the government, you have to meet their cybersecurity standards for your device. If you're a contractor of the government, then as an organization, you have to meet the cybersecurity standards. If you're an OEM selling to that organization, then your device has to meet those standards. So it's getting complicated. And then, of course, ITAR is a protection of data that has some serious consequences if you fail to maintain those restrictions. So, so the Department of Defense is certainly very proactive in establishing set rules now, and they're not easy to meet.
So, yeah,
so, it'll be a challenge for a lot of.
I believe it.
I think in the U.S. there's 300,000 contractors that have to be certified in the next few years.
Okay. Sometimes these regulations have a kind of a lighthouse aspect. It's the same in Food and Drug Administration. They, if you produce in Germany, they cover the Food and Drug Administration, although they never want to sell anything to US because it's kind of standard worldwide. Mm-hmm. And is it the same with the CMMC?
I would expect that. So CMMC is new, so we're waiting for the finalization of the rules, but they're expected to go in place next year. But for instance, Canada has already said they're going to follow the same exact rules. So I'd expect that to happen across the world, to have very similar cybersecurity standards requirements.
And it's possible that different industry sectors will adopt these too? Do you see that coming?
Yeah, it's very possible. And like the U.S. federal government, the Department of Homeland Security, for instance, has just said they're going to do essentially the same thing as CMMC. So I would expect it to roll out throughout the U.S. government. If you're working in the government in any way, you're going to have to meet these. And practically, that's going to engage, most of the companies doing business will have some business they do with the government. So I think eventually in the U.S. and probably coming to Europe soon is you're going to have a cybersecurity standard that you meet and probably have an auditor come in to audit you.
Mm-hmm. Moritz, what about you? Are you familiar with the CMMC? Is it a topic for you as well, or is it a faraway thing?
It's not a far away thing, but I think we're not at that point yet, because I cannot talk about how to make a supply chain secure if I don't know at the core how the supply chain works technically. So this is again coming to the point, how do I actually send data to the machine? Even if I would have a standard for how cybersecurity has to look like, and I'm still in that scattered vendor login proprietary format AM world as it is today, it's going to be a tough time, because then for each and every machine, each and every vendor, you have to go through that process again. You maybe have to change things, and then still the same question will arise, because there's a reason why the hardware manufacturers don't want to open their machines. And I think that's a discussion you have to deal with, and I think we have to answer that, and then the rest will follow, because I think in other technologies we already have solutions, and we just need to see how do we adopt them then later on to additive, and maybe twist and tweak them and tailor them to some specifics. But I think that's manageable. It's more about the culture and how the AM machine vendors place themselves strategically.
Mm-hmm.
I think, just to add on the point in the States, one thing that's going to change next year is the FDA hopefully are going to publish a guideline on what they're calling digitally distributed manufacture. So the idea of hospitals being allowed to manufacture Class 1 and Class 2 medical devices. Mm-hmm. Now, at that point, there's a lot of conjecture about, well, what's that going to look like? Because a hospital fundamentally will then become a manufacturing facility operating under 13485 and making a medical device to somebody else's design. So all of a sudden, there's going to be this issue of who takes risk, liability, and ownership. And I think then we are going to start to see the development of some quite robust data transfer between the device OEM and the hospital that's making the part in a very streamlined and secure way. But that's really going to be driven because the regulation will prescribe it has to be. So again, that's this thing. I think we're a little bit ahead of maybe where the market is, but it's going to happen. But yeah, I personally, I foresee this distributed model where you'll have an OEM with a medical device that is prescribed to be made on a certain type of machine by a certain vendor in a certain material. And to your point, you will stream that data and you'll pay per device. So everybody benefits in terms of the monetization of the intellectual property and the design, and the manufacturer gets it quicker because it's in the hospital.
But how can we bring it to the people? How can we bring it to the community, to the people who are reluctant, that there are solutions and that there are good upcoming solutions? What about the marketing? What about the aspect that they understand that there are solutions at the market? So it's...
Maybe so. We had the keynote from Daimler Trucks. I think they're quite a good role model showing what are the benefits, and then kind of reconsidering to what does AM promise in terms of flexibility. And we know the additive industry is not good at economies of scale. We're good in being flexible, being fast, and also like establishing a resilient and digital supply chain. And if you consider that fact, you can see that like cybersecurity and those supply chain considerations are like kind of right now the bottleneck to actually, make that benefits real and really, use the technology to the fullest.
Do we need a new certificate which is very useful or very obvious for the buyer, which says security proof or something like that? Do we need a new institution covering all the different aspects? Just that the buyer can be sure. Okay, this one is secure proof. Do we need something like that? Because it's if you dive deep into each of these industry sectors, it's slightly different, and you have different aspects of security, and it's so complicated. Do we need just a very, like a sign outside, and everything is fine for the buyer? Do we need a different layer of?
It's very complicated because you have one layer, say general cybersecurity hygiene, and devices should be doing certain things for kind of a base level of security. But even if they're doing those very well, protecting IP is really another issue, because IP protection, the difficulty there is when you go across organizations.
Right.
And having the best security protections within an organization doesn't really protect that when you're trying to share data with an organization. So there's really kind of two paths. There's one of general cybersecurity that you should use best practices around, but then also the protection of intellectual property, which is, even more challenging and at times more difficult to describe.
I think there's another thing. It's interesting. The title of this is supply chain, including cybersecurity and intellectual property. I think a lot of the time we forget there are only 4 intellectual properties: design right, copyright, trademark, and patent. And 99.9% of engineered products have none of those. So actually, all you're doing is protecting data. You're not protecting an intellectual property. So really, what we're talking about is the theft or misappropriation of data that's used to manufacture a tangible object. That's not protecting intellectual property. So I think we have to be careful. I did some work with the EU on this about 4 or 5 years ago on a framework for IP protection because of 3D printing. And what came out of it was we should ban 3D scanners, not 3D printers, because the 3D scanner is the thing that breaches the intellectual property, not the 3D printer. So I think we have to be careful that we're not talking necessarily about intellectual property solutions. We're talking about data security solutions.
I would agree and would say we're talking about protecting business models. So you don't want to share your 3D model because you don't want someone else to print it, sell the part, and shortcut you in a way. So I think it's more about data, and then business model is the
music industry. Aspect. The music industry, we all learned about the MP3 files, and so once out, they were gone.
Yeah.
They were, but I think you have to draw analogies. I always say, and if you're as old as me, if you remember Napster, So go back 15, 20 years ago, we had Napster, where you went online to some database, you had no idea where it was in the world, and you downloaded a film, and it took 12 hours to download it because it was taking a bit off a server here and here and here and here, and you watched this really appalling film, really bad quality, but it was free. Yeah, and then all of a sudden, Netflix comes along and says, well, I'll charge you $7.99 a month, but you'll get perfect quality for 1 million films. You don't have to wait 12 hours, but there's a little bit of money involved. And all of a sudden, Napster just disappeared. Yeah. So I think this idea of a marginal cost for the digital security of data, people will accept that.
Yeah, it's interesting because, I mean, as we're developing that streaming solution, obviously we also draw parallel to like the music and video industry. And if you look at additive manufacturing, it's layer per layer, and a video is frame by frame. So it's quite similar. I think a difference is when you talk about music and videos, it's not a hardware product in the end. You don't have something physically in your hands. It's just a digital product. So there is, I think, a different aspect to it as well. But I agree that we have to spend money on securing the data.
And as ever, it's not so easy as one wishes, yeah. maybe we have a short look. Somebody of you mentioned already Vibu, an interesting project with a new digital and IP-driven approach. Our mobile camera team captured here on the fairground. And the major keyword in this short video is data safety as well. And I will bring it to you and to our audience. Maybe we can have it on our screen.
We are working together with Daimler Buses, Nevo Bus, in the field of software protection and license management of their spare part business. So they want to sell just the digital encrypted blueprints of their spare parts instead of delivering the spare parts directly to customers via ship, via lorry, via plane. Yeah, you have to make sure that you don't lose your intellectual property. So in this case, you want to sell the spare part, but you don't want to lose the intellectual property of the spare part. So it's very important that you encrypt these parts so that only the people who are allowed to use these spare parts are getting access to these spare parts. So they are encrypted, and you get licenses that allow you to use it for the software to create a chamber room or to print the spare parts on a real printer in an additive manufacturing part.
Yeah, that was Stefan Bamberg from Vibu Systems who explained it. You must help me. How does it fit to our discussion?
So I mentioned Vibu because we're working with them as well. And I think now we need to go a little bit more into the technical details of how the machines looks today, because this aspect here is, I mean, it's generally true that we need to protect the data, but how we can achieve that is quite different for different machines, because different machines, so we have machines where you send the STL file directly to the machine and all the sizing and so on is done on the machine. And then we have machines where sizing and all that is already done and we just send the layer-wise data. And depending on which workflow you have to use and how the machine is set up, you need different solutions, because at one point you just protect the STL file, and the other slice data you protect like the layer data plus the process parameters, which is also kind of a secret for machines, material, and also I wouldn't say business model, but also some advantage and some USP for some companies. And depending on which machine you have and how the machine works software-wise, today we would have the need for different solutions. That's why I'm still advocating for, we need that standardized access to machines.
Mm-hmm. Yeah, I think, so Roku, for instance, the analogy in the pay TV industry, so Roku supports hundreds of app providers. All those have some DRM security embedded in them. The end customer never knows what those are, but it's up to the content owner to decide what level of security. But Roku has a process where it allows the content owner to manage that through downloading and installing their app. So I think like the Reeves solution or the Materialise solution, having the OEMs develop a process where they can support, many different types of security kind of opens up the opportunity. Because that's really the limiting factor now is trying to get embedded at the OEM level. But, having a system that is open the way that a Roku is, that allows the distributor to choose their security and implement it within the Roku API confines, opens them up to hundreds of solutions that you can install immediately.
Mm-hmm. I see. Yeah, this is a very complex topic we are diving here in. Maybe we have a look at our questions from the audience. That would be a good time that we do not miss. I don't know if you understood how it works. We have a roll up here where people can scan the QR code and have access to a tool. And outside it's a live stream as well, so that they can share their questions with us here on stage, so live. So it's, for me, it's always interesting how many people are watching our stream and having some nice questions for us. Okay, which one makes sense? The first one I don't understand. Okay. How does the process of licensing a printing company work? Is it a long process?
So, I'm assuming the question would be how if they want to acquire a security solution like the Materialise. So it's a combination of installing software at the engineering side, installing software at the manufacturing side, and then making sure that the printer that you want to use supports it. So it's most of the case now, it's just installing the software and then using that software to protect data, set your license, and then authorize it for manufacturing. Mm-hmm.
Do you want to add something or?
No.
No. Okay.
How the system works.
I must read your move. Then there is a question concerning the DRM license. How is it transferred to the printer? Doesn't it need to be supported by the printer manufacturers? Sure, it has to.
Yeah.
Okay. And how is it transferred? Is it just like an upload? It's like a software upload, or is it?
It's various means. So sometimes it's embedded into the build file. It can be a separate license that's uploaded along with the build file. It could be a license that the machine reads from a database. So there's various methods depending on the particular application.
Mm-hmm. Okay, I think that was it. There is one question for the presentation we had earlier. So there, he wants to have contact to Alex. So that's a good thing. So make contact. It's all about what we are doing here. Okay, coming back to our questions. I want to get a step up from our security business, and because I have few insiders here, and let's talk about the AM business in global. What do you think? Which are the biggest challenges we have to solve? That we see more AM applications in serious production, that it's more coming into life, into the real life of every person. I always think about the paper printers we once had. It was, if you wanted to print something, it was, there was one printing shop somewhere in town, and you have to go there, and there were several people in front of you before you can print your, I don't know, your university, your study or something, and then but everybody knew there is a place where I can go and print my product. And some years ago, when I understood the chances of AM, I thought, okay, it doesn't take quite a long time, and then we will have a lot of these 3D copy shops out there. But why don't we see these in the public?
If you want me to start, I think drawing parallels between 2D printing and 3D printing is a really bad starting point for any discussion. 2D printing at the most basic level is a piece of paper and black ink, okay? Now, you could go to trade fairs, and I'm sure they have one in here every year. There will be a 2D printing trade fair, and there will be hundreds, if not thousands, of different permutations of printer. There'll be a printer for making banners, a printer for making this, a printer for making that. And they're all made by different vendors with different technologies, different raw materials. So 2D printing is as complicated as 3D printing. And there will be a company somewhere in Frankfurt that makes pop-up banners. There'll be a company that makes... So it's kind of becoming the same thing. What you have is... You're never going to have one company that will 3D print everything in a local town.
But the path will be different. Do I get you right? The path will be different. So when we compare it to the paper printing, it was then there was no printing shop who could print all this stuff. They just could print paper. And I'm waiting for a 3D printing shop which can print just maybe one material and small-sized products, for example.
Okay, I mean, it's been tried. UPS tried it 7 or 8 years ago in the USA. UPS rolled 3D printers out into all of their stores in North America.
Okay.
And the problem is, either nobody's using them and it's a capital asset that's worthless, or you walk in to use it and somebody's already using it. So you either stand there for 4 hours with your USB stick, or you go to the next USB store hoping it's not being used, or you just upload it, wait a day, and FedEx ships it to you. So this idea of having localized capacity, it's kind of what's the point? I can get Materialise to make me something from my phone, and I'll have it in England tomorrow when I get home. So do I really need a local supplier?
To get it into B2C, would be the idea.
But if you wanted a T-shirt, would you go out and walk around Frankfurt looking for a company to print you a T-shirt, or would you just go online? Find the first thing that Google optimizes, order your T-shirt, upload your design, and not care about where it's made, and it's delivered to you tomorrow.
Mm-hmm. But I think there, like B2C and B2B is quite different. In B2C, it's like you more print gadgets and stuff for your home and nice to have stuff, but not like critical parts for aerospace, medical, and so on. And I think, thinking of like all the supply chain disruptions we've seen over the past years, it makes sense to have a really AMs hubs all over the world to bring like resilience to supply chains. But one general thing which we have already in 2D printing as a feature is missing in 3D printing. If you go to a print shop, you have a PDF, you print it, you get good quality. If you go to another printing shop, you have a PDF, you get good quality. If I have one build shop file with process parameters, I have it on one machine, good quality. I bring it to the next machine, bad quality. Even sometimes if it's the same machine manufacturer. And I think if we can solve that issue, then we will have it much easier to say, okay, now we can actually shift and balance within the supply chain, bring costs down, bring lead times down. So that's a perk which we need for 3D printing as well.
Mm-hmm. Okay. We are running out of time, I'm seeing. Let me give you one last question. I would be very interested in, when you are finished with this panel discussion and you're going on the fairground, what would be the first use case you're going to? What would you want to see today on Formnext? Have nothing to do with security or intellectual property.
Yeah, I think I'm going to go look at the concrete machine 3D printer back here.
Okay, from the construction.
Right.
But, okay. It was very noisy yesterday in the evening, so I advise you go there early because, otherwise you lose your ears. What about you? What are you?
I saw it yesterday. I'm going to go back, and I was telling these guys, there's a company literally just above us here in Hall 11.1. I can't remember. It's something like liquid silicon print. They have a really interesting process of making silicon parts, extruding curable silicon into a hydrogel. And so their support structure is hydrogel. It's the same stuff that's in shampoo. And they print in it, and then they take the part out, and they literally just squeeze away the hydrogel. And you can use it again and again and again and again. And you just have a part with no support structure.
Cool.
And you just wash it under a tap. That's really clever. I'd go and have a look at it, because that opens your mind up to so many other ways of 3D printing. So.
Moritz, what would be your highlight? Next step?
I would say I'm looking more for automation solutions, because especially in LPBF, we see, okay, I mean, we had quite a big growth over the last years, but now it's a little more steady, and now DD is more on the hype, I would say. And on the LPBF side, I really want to see automation solutions to bring traceability, bring quality, and ultimately bring the cost down. So in general, that would be the thing I'm looking for. So everything in regard to automation for printing, but also for post-processing.
I saw some of these Formula cars in that hall right there. Maybe you step by, and I think Shristi, my colleague responsible for the news, she wanted to drive one, but she was not allowed to. I wonder why.
That would be a highlight if you can make that work for me to drive one of those cars.
Yeah, maybe we go together.
Yeah, let's see.
Yeah, thank you very much, you three, for having you. It's a very complex topic we discovered, but we had not the idea of solving all these problems. But I think you gave very interesting insights in the aspects of the first steps and second steps in solving the problems, at least. But security, I think, will be a topic we can cover in 10 years. Yeah, thank you very much for being with me on stage, and thank you very much in our live stream for watching us. Thank you very much here at the stage. We will have a break here in our live stream and at the stage, and we see you back at 2:15 with our next hot topics. Thank you very much for watching, and see you then.